metal. You can make some holes, you can stamp, you can um, form it into the desired shape of the die. So the sheet metal is defined as the large surface area versus the thickness. It could be very small thickness. And you see there are multiple processes. So this is a list of shearing means cutting, bending, you bend the angle of metal, sheet metal, roll bending, stretch bending, blanking, punching, spinning, deep drawing, hydroforming, explosive forming. So all these methods, they are used to change the shape to form into the desired shape using these processes. So this is the shearing machine. It's like a cutting blade. It comes down and cuts the sheet metal. This is the picture to show you that you can change the angle. Before the process, it was a straight line here. It's a little bit difficult. But after this, it changes its angle. Okay, it changes its angle. So today we will do a one numerical problem. How much bending force required to suppose make an angle of 90 degree? If you want to have a 90-degree bend in the sheet metal, how are you gonna produce this? So that the punch comes here and then it makes or it can be a die like this, or and then the sheet metal is placed over here. Okay, this is a sheet metal and the punch is, it comes down, and this is the ray. So and it pushes it downward into the die. This could be a V-shaped die. We will discuss about it today. I'll explain you uh, the punching force. Usually I'm interested in two things: the bending force and the punch angle. Alpha punch. This is the punch angle. Okay, this is alpha punch. And what is this angle? Because the punch angle and the final sheet metal angle, they are different because of the elastic power, elastic energy restored inside the metal. We call this as a spring back. Suppose if the angle of the die is 90 degree, the sheet will not acquire the 90 degree, so it will have a little bit bigger angle. So we will talk about the final angle. How will you achieve the final angle and the ratio of the spring back to the final the punch angle. We will talk about it in a bit. Probably I explained it in the last lecture. This, yes, we talked about this already. So this is the formula. So I want you to write down, please write down this formula. This is for the strain hardening material. So we can, please write down this formula in your formula sheet. It will help you to find out the final angle of the sheet metal. This is for the case when you have a material which is strain hardening. So what I mean by that, look, I mean by that initially it is elastic behavior. You see the yield point, the stress yield, it happens over here. This sigma y is the yielding stress, and then it goes strain hardening. This goes this is where we start necking. Necking is a phenomena in which the material start going to break, fracture. So this we call it as a strain hardening material, plastically deformed here, and this is sigma 1. You will say Professor, this is sigma 1. That's the maximum stress which you can push the material into. Okay, beyond that, it will start fracturing. Okay, so we will solve similar problem today. Okay, okay, now let's see. So, okay, let me come back here to show you some of the slides, then I will start the problem for you. Bending operation. This is another machine which is trying to bend the sheet metal into different shapes. This is another machine. How are we performing the press brake system here? Okay, please draw this diagram in your notebook. Okay, so you can also look at this is the alpha die angle. Okay, this angle is die angle, and this angle is actually this is the angle alpha punch. Okay, so you will see alpha punch plus die angle on the right hand side and on the left hand side. You see my point, guys? So 2 times alpha die angle and plus the punch angle becomes a straight line. Do you understand this relationship? So this is important that you understand some of the terminologies of the punch and the die angles. And also there is also one thing. This is L. The bending is taking place over here with this axis of rotation. So if the force comes down, here, so please write down this formula here. I'm gonna show you one formula that how do you find out the punching force. 2 times bending moment divided by the length, which is the moment arm, as I mentioned, from this point to this point. Mu times sine alpha cosine alpha. Alpha is the die angle. So alpha, it depends upon the coefficient of friction. One second. Sheet metal analysis. This is the formula. When you exert the punch, there is some reaction force at normal along the tangential component, which is the mu n times n. So alpha is the maximum force is at an angle 2 point like at this angle. Okay. So if you do the process without the V-shaped die, you just bend it in air. We call this process as air bending. Like this is not touching the die, but it is also the shape is looks like a V, but it is in the air. It is not bottom touching, you see. And there is another process of sheet metal that you bring the punch to form the die, the lower die, and there is a rocker type punch which shapes the sheet metal for the desired angle. Another kind of die is known as the wiping die. So these are a few more uh, pictures of the bending sheet metal, roller bending like galvanized corrugated sheets metal for the roofing. Okay, it looks like you see, it's like metal roof with the corrugations, the grooves. So these are all sheet metal process. This is another type of sheet metal process, blanking and punching. You either you have the waste. When you have a waste, is a scrap coming out, and you need the sheet metal as a final part, or you have a punching process in which you need the blank which comes off. Okay, so another kind of process of sheet metal is spinning while you are heating with the torch. You are producing the shape of the mandrel and pushing it along the mandrel surface. You start creating it. I believe the parts in our house, the pressure cooker, is like a sheet metal bending. It acquires the shape of the mandrel with the push of the tool. Yeah, you see, this looks like a process to perform the sheet metal in like in a pressure cooker. This is the car fender. You see, major car processes which is the body of the car is all sheet metal working. These are the big punches and the shapes are adopted according to the. This is another type of hydroforming. With the water pressure, it pushes the sheet metal to acquire the shape of the die. Hydroforming. These are the manufactured part from the hydroforming process. There is a die process, die and the metal coming out of it. Explosive sheet metal forming. You have some explosive material because of the high shock waves. The sheet metal bends and acquires the shape of the die, and there is a vacuum line. The air comes out of the die through the vacuum. So we have gone over the many sheet metal processes today. So let's do the one problem, okay? So let me start one problem here. So bend a metal plate of steel to 90 degrees using a bottoming punch die set. Estimate the punch and die angles, determine the maximum force, the bending force, okay? So determine the maximum bending force, and this is the data provided to us. So let me grab this is the data. Let me grab this picture again. I want to show you. Okay, let me go over here. So this is the material. Sigma yield has been given. Okay, sigma yield has been given, and the maximum stress is given. So it will look like this shape. Okay, the stress strain curve. It is a yielding happens at a straight line. The first you have to draw this straight line up until yielding starts, and then comes the strain hardening stress. You keep on doing the bending in the plastic region. Okay, this is in the plastic region. So this is the maximum stress, which is 80,000. So this is 80,000, and the yielding is happening at 50,000. And here This is the happening at point 4. What is this value? So we can calculate that value, is no problem. So you know there is a stress strain relationship. Stress is equal to strain times Young's modulus. This is about the yielding point. And then now s- sigma y is 50,000, right? 50,000. So what is E? We can find out E from this relationship. E equals to sigma y over Young's modulus. What is Young's modulus? This is 29 in 10 to the power 6. 29 in 10 to the power, sorry. This is my sigma y, which is 50,000. Sigma y is 50,000. Okay, sigma y is 50,000 divided by E, 29 in 10 to the power 6. What do you get in decimals? Please open your calculators. Let me know. 4.17%. So this is a point 0017. Okay, good. And this form. So if I write down here sigma, the the formula for sigma, it is sigma yield plus K times E. This is the tensile stress. This E is different from this E. So what is E in our case? We call this as E tensile. And if we go back to the formula here, so let me show you over here. This is the E tensile. Because at the bottom, let me show at the bottom, the sheet metal after the neutral axis is under tension. You see, this sheet metal is like a tensile stress, okay? But on the top, it is like compressive. After the neutral axis, this is a neutral axis where there is a change from compression to tension. You see my point? So how do you find out? How do you find out this E tensile stress? So this is a formula. There is a formula here which you can use to find out. So let's grab this formula. What is that formula? This E is E tensile, okay? Okay, let's see. How can we find out E tensile? We do have some data given. Okay, look at the problem. Radius of the punch is given. It is 0.155 inch. Okay, it is 0.15. So this two, this is going to go into the numerator of this value. So can I write down 2 times 0.15 because this is the radius of the punch. Okay, now look over here, divide by the thickness of the sheet metal. The thickness of the sheet metal is 0.05 inch. Okay, so this is the thickness. This is the small plate thickness. It's very tiny as compared to the breadth. Okay, now let me write down here 0.05. How much is the E tensile? Is it 0.143? That means it is 14.3%. For this punch radius, for punch radius of 0.515 inch, you can achieve this much, the neutral axis, this much stress. Okay, it's like E tensile. Now make sure it doesn't touch the point. It doesn't go above zero point 0.4. If it goes above zero point 0.4, it will start fracturing from the bottom. Why? Because the necking will start. You know what is the necking? The process in which the material starts fracturing and becomes thinning in the cross section. This is not. So the necking will happen at the maximum elongation of zero point 0.4. So your stress with this radius should be less than 0.4. You have to check it. If it is less than 0.4, it means your material will not start necking. It is true. You see that? So you have to do this check and balance and keep on track that this process will not create some fracture. I want to show you a picture of how the fracture happens. Maybe I can show you over here. Did I show you it? Let me show you a picture here. The in the bending process. Yes. You see the cracks start developing. We have to avoid these cracks during the manufacturing. Okay, let's come back to our question. We have to find out the maximum bending force, and how do you find out the sigma 1? Let me show you the formula. The formula for the bending force is this formula. Now, for this formula, you need to find out MB. What is MB? Let me show you the MB over here. I think I explained. Yes. Did I show you this formula earlier? This is for strain hardening material. So I'm just revising what we studied last time. This formula is going to help you to find out the bending moment. Okay. So let me go back over here. Let's use this formula. Okay. In order to use this formula, we need to find out what is sigma yield. So what is sigma yield? It is given. Look, sigma yield is 50,000. Agreed? So let me show you. Over here it is 50,000. What is the breadth of the sheet metal? 1 inch. And the thickness? How much is the thickness? 0.05. Agreed? This is 0.05. 0.05. This is 0.05 square. And sigma yield is 50,000. Then you will be asking, Professor, what is sigma 1? You see the law. The sigma law is here for strain hardening. This is uh, the rule of the stress strain curve. I will say stress strain curve. Okay, you have to take this formula. So I'm going to write down this formula. Let me write down sigma equals to sigma y plus k times e. Sigma y is 50,000. And what is k? Imagine this is sigma 1, and k you have to find out from this. And e you already found. It is the tensile stress 14.3 or 0.4143, 0.143 K. Now K is nothing but a slope, rise over run. Look, this is my rise, this is my rise, this is my run. So this is my K. Okay, everybody knows how to find out the slope, right? So what is K? Rise is how much? 80,000 minus 50,000, and run is how much? Zero point 0.4 minus 0.0017. So let me write down K over here in front of the picture. So rise is how much? 80,000 minus 50,000. Run is how much? Run is zero point 0.4 minus 0.0017. You agree with your professor? How much do you get? If you do the math, you should get, you should let me know if you get 75,320 psi per yes, it's psi because strain is nothing, no dimension of the strain. Okay, do you get the same answer? He confirms. You confirm. She confirms. You confirm. Okay, that's good. Very good. So now let's plug it in MB. What is my bending moment? This is first of all let me explain to you what is my K. K is 75,320 psi. And let's plug it in over here. Plug it in over here. And what is sigma 1? This sigma 1 is gonna go into the bending moment formula. And what is sigma 1 now? Look, 50,000 plus 75,320 psi times 0.143. How much do you get? Do you get stress of 60,771 psi? Please confirm. Yes. Yes, he confirms, she confirms. That's good. Now let's plug it in this formula of the bending moment. So let me grab the bending moment formula here. So MB, the bending moment is sigma yield, the breadth, the thickness square, divided by 12, 1 plus sigma 1 over 2 sigma 1 over sigma yield. If you do the math, you get this much bending moment. Moment is like torque. Unit of torque is Newton meter in SI system, or pound force inch in FPS system. This is in inch system, foot pound second. So we have to write down the in system. Now, guys, after we do this, we have to use the bending moment. After we do the bending moment, we have to find out the maximum force. What is the formula? So the maximum force formula is here, uh, over here. And this formula, it uses MB, and we already calculated MB. We already know what is the length of the moment arm between the punch and the force acting at the die contact. You see my point? And you can find, you already know what is the coefficient of friction in the data. It is given, it is 0.1. Usually we are given with the 2L. 2L is the total length of the die from this corner to this corner where the sheet metal is expanded. Okay, that is 2L given. So you have to divide it by 2 in order to find out that L is going to go over here. Okay, you understood? And what is alpha? This is for the maximum. So alpha you can find out for the maximum angle. There is a formula. I think I explained it to you a little earlier. So let me show you over here. I can write down, I can write down here the formula for alpha. Okay, what you have to do. So alpha, yes, I'm gonna write down over here. Alpha you can find out with this form. Alpha equals to 1 half tangent inverse mu. This gives you the maximum angle. Okay, so what is that? So 1 half tangent inverse mu is zero point 0.1. It is, if you calculate it, do you get 2.86 uh, degrees? Please confirm. Will you, a professor? Yes. Dimitri says yes. John says yes. Tom says yes. That's good. Malala, you say yes. Noah, you say yes. That's good. Everybody is with me. And now look, we have to apply this formula. Everything is done. Use this formula to find out the maximum amount of the bending force to acquire that much angle. So let's use, I'm going to grab this formula here and you will help me. Okay, open your calculators and you can start calculating MBL cosine square alpha plus coefficient of friction mu sine alpha cosine alpha, and then 2 times what was our bending moment? 35.74. 35.74 divided by the length, half of the length between the two corners of the die, which was actually, it was 2L, 2 inch, so half is 1 inch. You agree with me? So 1 inch. Okay, now this is complete. Then we are given with cosine square alpha. The alpha is the maximum die angle for that particular punch radius. The coefficient frequency is 2.86, so you will use that one. Okay, 2.86, 2.86 sine 2.86 cosine 2.86. Can you do the math? Let me know if you get 71.7 pound force. If you get this force, then this is the maximum amount of force which you can achieve with this coefficient of friction. Okay, that's the maximum. Yes, you confirm it. Are you still doing? Okay. Anybody else who confirms it? Pamela says yes. Emmanuel, Henrik, Beatrice, Will, Nicole, you got it? Mihai. That's good. Everybody is with me. That's good. Now we have done the answer. The first answer we already calculated. Determine the maximum force. You already have determined the maximum amount of force. The next thing is estimate the punch angles, the die angle. Okay, how are you gonna estimate the max the punch angle? And then so now I'm gonna go back to this for the strain hardening material. You have to find out this ratio. I'm looking for the ratio of delta L to alpha for the spring back spring. It's just this is the okay. So I need this. Oh, 1 second. I don't need this. This is strain hardening. So let me go back over here. Yes, the final answer is this one. A final formula. Final formula is this one. So you have to use this formula in order to find out this ratio. Once you know this ratio, then I tell you what is the relationship between this. Because I know delta alpha. What is delta alpha? Look, over here, this is my punch. Okay, try to understand. This is my punch, and this is my Okay, let me redraw it here. This is my die. Okay, this is my uh, die here, or sheet metal here. This is the die. Okay, suppose this is the angle. Okay, now look over here. This is included angle of the punch is alpha p. That is the angle alpha p. Agreed? You understood this? And now this is the included angle. And now the sheet metal after the punch is complete. This is the final. So the final angle is, and this is the spring back, delta alpha on the right hand side, delta alpha by 2 on the left hand side. It comes back even after the bottoming punch. It comes back. That is elastic. We call this elastic energy, which changes the angle. What is that? Alpha final minus alpha punch. Agreed? And now if I write down, divide by alpha punch on both sides. Alpha punch, alpha punch. So what is that equals to? So I can write down here that is equal to alpha final this is just a math algebra. So now look, alpha final is 90 degree. How much is alpha final in our question? It says the final, um, let me see, the bend plate to a steel to a 90 degree. You have to bend this sheet metal at 90 degree. This is my alpha final. And punch and die set, and this alpha final, okay, that is 90 degree, but alpha punch, so I need to find out what is my alpha punch. But for that we need to find out this ratio. Look, can you use this formula to plug it in over here? That will give me just a ratio. Okay, let's do this formula. Can you find, let's do this, alpha delta alpha punch equals to rp. How much is the radius of the punch? It is 0.15. If you look in the data, it is 0.15 inch. Thickness of the plate is 0.05 divided by 2. Sigma yield is 50,000 divided by the elastic modulus, which is 29 into 10 to the power 6 times the thickness 0.05 into 1 plus 2 times sigma. Sigma 1 is, we already calculated sigma was 60,771 psi. So I can write down here 60,771 psi divided by sigma yield. You get this ratio 0.021, right? Please confirm in your calculator. Open your calculators. Let me know, what do you guys get? Yes, you confirm? James, Thomas, you confirm? Beatrice, she confirms. Now look, the final formula. I'm going to finalize this answer. Look, I need this formula to find out the alpha punch to acquire this radius. Look, you will help me, okay? You already found this ratio. Alpha point is 90 degree, 1 plus 0.021. Can you do the math for finding out this punch angle? That means alpha punch equals to what? 88.1 degrees. It should be less than the included angle. The punch radius should be a little bit less because of the spring back in order to achieve the exact 90-degree angle of the final sheet metal bend. Do you get the same alpha p? Yes? Yes? Will? Behind? Lower? Louis? Yes? Yes? Malala says yes. Okay, good job, guys. Now you are learning. Are you learning the material? Can you solve such problem in your quiz next week? Next week, Tuesday or Thursday? You let me know. You tell me. Camila, it's your chance. If you say Thursday, and Beatrice, you Tuesday, right? Will, okay. Bending, only bending. Or maybe I will see polymer injection. Maybe I want to see because it's gonna cover in the final. What did you ask me? Yeah, I'm gonna open the homework today for the bending. Bending plus I'm gonna open the second homework, which is our final. Two home because time is short. I will open all the homework with their solutions. So you practice. Yeah, you will prepare. Yeah, final is on. I'm gonna give you a non-cumulative bending process, similar questions, plus polymer injections, and maybe the cost part of the machining because machining is a big topic. Remember, I covered the cost part from here. This is all cost. One question: how to find out the cost of the machining process? Not the machining process itself, just the cost. Just three topics. Yeah, it's good. Three topics you can handle easily. Make sure you practice. And I'm gonna give you solve problems for your home because you will learn. I want you to learn it. What do you say, Beatrice? Thursday we are just machining and extrusion, including the cost. Or should I exclude it? You let me know. What do you say? Cost include or no? Maybe in the final, I final and this quiz. This quiz, coming quiz, bending and the if you are excluding, it makes sense to me. I have to give you some hard time. Little bit hard time. Good. Some stresses are good for your future learning, and I'm concerned about your future learning. You should not have fun in the summer. No fun. I know you have a lot of funs on the weekends, right? I know that. Okay, now come back to the question. Are we completing? Now we have found the alpha P, but we haven't found the alpha die. It is asking you the punch and die angle. Usually it is asked together. Okay, now you remember I showed you this relationship. Okay, let me show you. Let me show you. Do you remember I showed you this relationship? So if you have this die angle, alpha die, alpha punch, alpha die. So what is the total, the length angle of the line? What is that angle? 2 alpha die plus alpha punch equals to 180. Agreed? So if you have alpha punch 88.1, can you do the math to find out the alpha die? If you do the math, do you get 45.95? degrees. So we have found both. You got it? You got it? Good job, guys. You are doing good. You are smart kids. Very good. I want you to, when you graduate this class, I want you to have knowledge. And I have opened my lecture notes for your future. Download them for your future jobs. It's going to help. If you find a company manufacturing, these are the processes. Even if it is AI competition, but you still need some formulation. All right. So have you understood this question? No problem. Okay, let me show you. This is the end of the sheet metal bending. Let me show you the solution provided in our slides here. And I'm gonna open another homework for you, which is giving you the practice because the solution. Do you want me to include the solution along with the homework? You can submit the same solution, but do it by your hand rather than copying paste. Do learn it first. Learn it. Do it. You promise not to copy paste. Learn it by from the solution and do it by your hand. Good job, Beatrice. You're doing good job. Hmm? Yeah, sure, no problem. Let me open it right now. She requested me. I'm gonna give you. What assignment you want me to open for you? Almost 7. Right now, I can open it right now. Okay, now you can submit it. Tonight is okay. You see, no problem. But do good in our quizzes. Our tests are more important than because I give you the solution. The learning purpose. Quizzes, you have to show me your performance on the quiz day. Tomorrow, the day after tomorrow, spend 6 hours today and 6 hours tomorrow to finish machining without cost a question. You see, I'm listening to you. Will you listen to your professor? I want you to spend time in learning. Okay, now have you understood this how to find out the K value, the strength coefficient, and how to find the bending moment? Use these formulae. Okay, and then the angle for this coefficient of friction and this punching angle, what is the maximum angle, and this was the ratio for the actual ratio. So over here, this is the punch angle 88.1, and it makes sense to me because if you reduce the punch angle, it will further push this down into the die, and the die will become, the sheet metal will have 90-degree. So this is the end of the next topic is just for your own learning. I'm not gonna include this in your exam. This is sufficient up until here. This problem is sufficient for you to solve the problems on the quiz next week. Any questions, ladies and gentlemen? You guys are good? Okay, before I go to the next topic, polymer injection, I want you to do me a favor, open your D2L and see if you have received a message from our department, whether, let me open something, close this. Okay,